This video was produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. A histogram is a graphical representation of continuous numerical data. It is similar to a bar chart. However, there are no gaps between the bars on a histogram. The advantages of histograms are that it is easy to see the shape or distribution of the histogram, and they provide a way of displaying frequency of occurrence. We will discuss the shape and distribution in a later video. The main disadvantages of histograms are the use of intervals prevent exact summary statistics, such as the mean, mode, and range value being calculated. We also lose a lot of the original information, as we no longer have original data points, but instead intervals and frequencies. Let's move on to constructing a histogram. The question states that below is a list of science grades scored out of 50 for a class. Construct a histogram to represent the data. It is easiest to draw a histogram from a frequency table. So the first thing we will do is make a frequency table for our values. A frequency table consists of intervals and the frequency or number of times the number from our data set lies in the interval. It is easiest if we pick intervals of the same size or range. Looking at our data set, our data values range from 7 to 49. In this case, to pick intervals that are easy to work with, I'm going to stick with a size of 10 for each interval. So our first interval is 0 to 10. Our next interval is 10 to 20, then 20 to 30, and 30 to 40, and so on. These intervals represent grades, so we'll state that in our frequency table. Now, to complete our frequency table, we'll see how many numbers from our data set fall in each interval. So for 0 to 10, one number falls in the interval. From 10 to 20, two numbers fall in the interval. For 20 to 30, four numbers fall in the interval, and so on. And we will label our frequency table with the number of students, as this is what the frequency represents in this case. Now, moving on to construct our histogram from the frequency table. I have labelled the x-axis with our interval label of grades, and I have labelled the y-axis with our label of frequency, number of students. The next step is to divide the x-axis into equal sections representing the intervals. So in this case, it is 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 50. We will do the same for the y-axis. In the case of the y-axis, we can see our largest frequency is 10. So based on this, we might divide the y-axis into twos. Now, to draw our frequency table, we look at the first frequency and its interval. So this is 0 to 10 and it has a frequency of 1. Now to draw this on our histogram, we need to draw a rectangle so that it has a height of 1 from our frequency or our y-axis, and it goes from 0 to 10 on our x-axis. Looking at the second interval, 10 to 20, it has a frequency of 2. So the same idea, this time we go up to a height of 2 and we draw a rectangle so that it's between 10 and 20. Our next interval is 20 to 30 and this has a height of 4. So we need to draw a rectangle so it hits the frequency of 4. The next one is 30 to 40 interval and this has a frequency of 10. So we draw a rectangle so that it hits 10. And our last one is a frequency of 5. We can rub out the dotted line afterwards. This was just used as a guide. And now we have completed our histogram for the data values. A few points to note about histograms is that another name for an interval is a class or group. Let's consider some questions we could be asked about this histogram. The first question we're going to look at is, what is the modal interval? The modal interval is the interval that has the highest frequency. In this case, we can clearly see that the interval 30 to 40 has the highest frequency. So our interval is 30 to 40. Second question is, how many students scored less than 20 on their science test? So if we mark in where 20 is, students in the interval 0 to 10 or in the interval 10 to 20 scored less than 20 on their science test. We can read across the values in these intervals. For the interval 10 to 20, it has a frequency of 2, and for the interval of 0 to 10, it has a frequency of 1. So 1 plus 2 will give us 3. So 3 students scored less than 20 on their science test. Question 3 asks us how many students in total were in the class. This time I will add up the frequency from each interval. We already know from the previous question, in the interval 0 to 10 there's 1 student, between 10 and 20 there's 2, between 20 and 30 we can read off 4, between 30 and 40 we can read off 10, between 40 and 50 we can read off 5. So adding 1 plus 2 plus 4 plus 10 plus 5 we get 22. So there are 22 students in total in the class. The final question asks us which interval contains the median value. As there are 22 students in the class, the median value has to be the 11th or 12th student in the ordered dataset. Please see the video on median for further explanation of this. Starting from 0, there's 1 student between 0 and 10. Between 10 and 20, there's 2 students, that covers 3 students. Between the intervals 20 and 30, there's 4 students. So far we've covered 7 students. In the interval between 30 and 40, there is 10 students. So since we have covered 7 students, the 8th student to the 17th student would lie in this interval. Therefore, the 11th, 12th student will be in this interval. So the median value is contained by the 30 to 40 interval. That concludes the discussion on histograms.